Let's see another problem today. It's a valid parenthesis. So let's first understand the problem and then we'll go for the solution. So the problem is given a string containing just the characters like this kind of brackets, and we have to find out this is the valid parenthesis order or not. So what is the valid parenthesis or what is not, we can understand by examples. So if there is an opening bracket and if there is a closing bracket, then it's a valid parenthesis order. So in this case we want to return true. And here also, if you see opening closing and the same kind of bracket, opening closing, same kind of bracket, opening closing, that's a true. So that's a valid. And then this one, there is an opening this kind of bracket, but we got closing for this big bracket, so this is false. So this seems simple. It's an easy problem, but it's some kind it can be tricky also. So let's see how to solve this. So think a little bit and then come back and see like how we want to solve this problem. So from these techniques I have already discussed in last 22 videos. We can choose one of this technique from here and then we'll try to solve the problem. So for for for, for this problem I'm choosing the stack, and with the help of a stack we're going to solve the problem. So let's see how we'll solve with the help of a stack. So I'm thinking like when we can iterate through each character of the string. Whatever the string we have got, we can iterate. Like let's say we got this character, this string, then we can iterate one by one. And whenever we see opening bracket, like a small bracket, this big bracket, curly bracket, whenever we see the opening, that's later we can push that in a stack, and we know the nature of the stack, so we can push that in a stack. And whenever we see the closing bracket, we get the item from the stack and see if there is a match. If there is a match, okay, good to go, we can proceed for other character and again see the match. If you take another character, see the match, and in that case we can return true, otherwise you can return false. So let's see the code and we'll try to understand. So first, the first thing is, I can check some conditions, like if there is only one bracket in a string, that is the invalid situation. So I can check quickly those things, like if length of string is equal to 1, then return false. Return false. So one bracket in the string is always false. Okay, so that's good. What can be other conditions? If the first character in the string is closing, any closing, it's a small bracket, big bracket, or curly bracket, any closing, that's also invalid situation. So let's check that also. So if is 0 equal to this bracket, or s0 is equal to this big bracket, or s0 equal to curly bracket, so then in this situation we can return false. Because that's a false, because that's not a valid parenthesis order. Okay, in another scenario, then we need a stack. So let's define a stack. So in a golang can define a stack using a list. So list.new, and the stack is defined here. Now iterate through this is string. So for, you can say that's a letter, and range string. So we'll get the letter one by one, and we can check if L, we're going to check if L is any kind of opening bracket, a small or this opening bracket, then we'll push that in a stack. So if L is equal to this small bracket, opening bracket, or L is equal to curly opening bracket, or L is equal to big opening bracket. So in that case, push this character in a stack. So stack. So golang, the function is push back. That's a letter. So we push back. Else in other scenarios, if it is a big bracket, I mean it's a big closing bracket or a small closing bracket or curly closing bracket, any kind of closing bracket, if we encounter that in a string, then we have to remove that item from the stack. But we have to also check, if the stack size is greater than 0, then only we can remove something. If there is nothing inside that, we can't. So let's check that condition also. Else if there is something in a stack, so it's a stack dot length greater than 0, then we are going to remove some item from the stack. So whatever we'll remove, we are expecting that can be the closing bracket. So if you get some closing bracket, then we'll see the L has corresponding opening bracket, and if it is not, then that's not a valid. So here we can check if, okay, first remove the item from the stack. So stack dot remove and stack dot back. So that's going to be element, and I can say that's a letter 2 element, and that's a element. This a type is so uint 8 yeah. Okay, so we got that item L2. And now we're checking if L2 is equal to this closing bracket. If it is, we're getting the item from the stack, and we know, so in a stack in a stack we add only opening bracket, so we can check for the opening bracket. So if a stack item is opening bracket, and then we know that if in something in a stack we have already put, and that is opening bracket, then whatever the new things come from this string iteration, that should be the closing. Like let's say you put this item opening bracket, and this item, that if you see that, okay, this item is this small bracket, then a small bracket goes to the stack. The next time we encounter the closing bracket, so if you get the closing bracket, then we are going to get one item from the stack, and we get this opening bracket from the stack. So you're checking if this is a stack item is opening bracket, and our character L not equal to opening, this one, then return false. So but in this case it's not going to encounter this situation, because we added this one in a stack, and when we iterate this string, the second time we got the closing bracket. So when we get the closing bracket, we'll come to the else conditions, and then we we get item, we remove the item from a stack and we get opening bracket. So L2 is opening bracket, but L is closing bracket because the second item closing. So that condition match, so we are not going to return false. But if that is not a closing, then only return false. So in this way we can check other conditions also in a similar way. So else if L2 is equal to curly bracket, curly opening bracket, and L not equal to closing curly bracket, return false. One more condition, if else if L2 big this curly bracket and L not equal to closing curly bracket, return false. Okay, so in all these conditions we return false, and here also if something in a stack, if there is if the stack is empty, if the stack is empty and some new character comes like the closing bracket or something, so that's also a invalid situation. So in that case also we can return false, and then we come out of this loop and we can check if the stack length is greater than 0. So after after all these operations, if you see if there is something left in a stack, then that's also a false condition, return false, and then otherwise return true. So let's run this and see. Okay, so it's saying int 32 not doing the interface conversion. So we are storing that L is interface conversion, interface is not int. Okay, let's do that in 32. Let's run this. Wrong answer. Why? Let's analyze these scenarios and just check why it is wrong answer. So you'll get the first thing, and then as soon as we get this opening bracket, we'll push that in a stack, and the second time we get closing bracket, so this will come here, and we know that the stack size is greater than 1. Then we'll remove the item. It's a pushback, stack back. Okay, remove the item element. We got the item L2, and then if the L2 is this and L1 not, so okay, so this should be closing bracket. Okay, so let's run now. Okay, accepted. Submit this. Okay, good. Okay, so it's a beats 100%. That's nice. We'll see same solution for the same problem in a Java. Java. So same thing I have checked here also, like I'm checking the length is 1, then return false, and then get the first character, and if the first character is any closing bracket, then return false, and declaring a stack here, iterating through this string, and getting the item one by one here, and checking if any opening bracket, then put that in a stack. Otherwise, If the stack size is greater than 0, if there is something in a stack, get the item L2. And the similar we're checking the condition in any opening bracket, and opening bracket comes from a stack, and from the string if it is not a corresponding closing bracket, then return false, otherwise return false, and at the end also return true. So that's all for today. Thank you.